Hello again, a new day, another project. In fact, it's not a project, it's a review. Some very nice guys from Kaiweets, they send me something to review, something to observe and to report, of course. And this came from Germany via the HL. And let's see what's inside here. They just send me something to review and to keep it eventually. And of course, I'll do the best to have a really impartial review to help them to create a real image of the products they are doing. Once again, it's not sponsored. And okay, here we are. KM601. And here we are. Oh, it's pretty heavy. It's like maybe 600-700 grams. And we have a booklet also, a manual, user manual. I have to say that this is pretty consistent. Whoa, it's a lot of learning here. Nice case. It feels strong. Well, I found, after my opinion, cases. I'm never using cases, you know. I'm always just grab the multimeter and do whatever. But it's nice. It's a nice touch to have this around. And you see, the most important thing, to put back the instruments in the cases. Never happened to me. I'm sorry. But anyway, I appreciate that. It's really nice. There we go. So, okay, so these are the testers. We have evidently a temperature sensor, 6 batteries, and here is the multimeter. Wow, I have to say this is big. Look at my ancient M890G. I can't even remember when I bought this. I think this is more than 20 years old. And look at this guy, almost the same. It's really big. Let's take a look first. Well, these are real touch switches. You can hear the sound. So it's not just a plastic something. It's rubber or silicone rubber something. It feels good, and the screen is huge. I like that. I like that because I'm wearing spectacles anyway, so it's good to have a good view about. Here we have an NCV. Well, that should be a sensor. On, off, no batteries, evidently. This is the torch. That's a nice touch. APO. Auto power off, I suppose. Oh, and this is what I like. You know, it's great to have the testers this way. Come on. You know, it's so funny about scissors, you know, because usually this one is working great. But I've been cutting a lot of tape in the last projects or something, and it's full with glue, or what the hell is that? So once the scissor is infected with this kind of glue, it's not cutting anymore. I have to clean it. And what I was talking about, the tester should be applied here. But you know something, in this situation, I think a proper design for the tester will be to have it, you know, like a straight banana, not an L banana like this. But you know something, it's perfect. And we can do it like that. Uncommon, of course. So we have 4 inputs. Okay. Why I am not looking. Okay, so the testers are on. Well, this this plastic, I mean the isolation, it feels pretty good. I'm not sure if it's siliconic or something, but it's pretty flexible. Yeah, it's okay. Cat-free 1000 volts. Cat-free, okay, so that one, it's Cat-free 1000 volts. This one is Cat-4 600 volts. Why? Maximum 10 amps. Well, I don't know. Anyway, I'm not working with 600 volts, no way. I let the professionals do that. I'm just a hobbyist. And we have these things here, these caps. Oh, the other way. That's an interesting thingy, you know, to have this covering and you can go a little bit in. That's nice. Okay, so the testers are pretty okay. We have the thermocouple, how we call this, the thermic sensor. This is okay. This is that kind of beam metal sensor. You know, here are two kinds of metals soldered together, and once, you know, they have different temperature coefficients. So that's why the current get unbalanced somehow. I think one is iron, the other one is copper. We'll check this later. I think we have a kind of, there is a plastic film here, it's just for protection, you know, for transport or stuffs. That should go away eventually. But now I have to take this off, because evidently this is a cover. Well, it can be better, kind of plastic, but it's pretty okay, in fact, pretty malleable and good grip, you see. It have all these things here, you can have a good grip. So there is no hanging something, you know, magnet, or at least to have this, but that doesn't really bother me because I'm not using that anyway, anytime. Okay? We got two fuses inside, 600 milliamps for 250 volts and 10 amps 250. Okay. Now I suppose we have to take off some screws to have the batteries in. 6 batteries or something. This? Let's try with this one for the beginning. Okay, this is out. Oh yeah. Oh, very simple. Good to know. Only 3 batteries. These are AAA. Plus, minus, minus, plus. And shall I put this back? Okay, let's put it back. I got no intention to open it up. I can tell you from now. 1, 2, 3, 4 screws probably. But I don't want to open it up yet. So be patient, because I will open it up someday for sure. I know me. There you go, people. Wow, it's a huge LCD screen. It's really nice, you know. So as I can see, the multimeter, it's starting on auto. We have a temperature control here, 19.6 degrees, maybe. Volt, DC and AC, ohm meter, resistor meter, let's call it, and a beeper. You see, we have these green ones showing us where to insert the testers. Usually the black one it's common or ground, and the red one it's plus. What shall we measure? Let's measure some batteries, as long as we've got them here. So it's only 3 batteries, and they've been nice to send 2 sets of batteries. That will stand for 2 years or something anyway. Auto, and it goes directly to what it feels, you know. It doesn't, I was afraid, you know, being on auto, I was afraid it's, you know, mixing resistance with voltages and stuff like this. Let's shortcut the testers. Yeah, Nice. I done nothing. It's knowing by itself. Okay, let's check this one. This we'll consider a kind of resistance, no? It's beeping. What do you think? I think it's beeping because it's in very low resistance. Okay. Ohmmeter and continuity in the beep mode. Okay, so this is for the beginning, you know. Okay, what is this? After, oh no, auto power off. So we got this sign here. If you want to take it out, the sign is disappearing. When this is on, probably it will shut down after a while. I'm not sure. Okay, let's check the manual. Press and hold the button for 2 seconds. Okay, press the LPO button to turn off. Okay, 15 minutes. Where is the flashlight? Okay, let's go to each function manually. Of course, volt, continuous, and alternative. So as you see, this is a True-RMS multimeter, and I'm gonna make this little guy here to generate some frequencies and some voltages. Let's see what we got. We are still in DC. Why? Why? Should be alternating current. We are on auto? No, we are on DC. I can hear a click inside, so that should be a kind of relay. Select. Oh, now we are talking. So you have to select voltage and then select in manual mode. Look there. True-RMS 2.486 at 50 Hertz. And we have the frequency up here and the voltage. Okay, let's try 10 Hertz. Oh yeah, look there. 10 Hertz, 2.374. Nice. What else? 1000? Beautiful. 2.339. Almost the same. 10,000? No, not anymore. 5000 Hertz? Probably a sinusoidal signal will pass, but this is a square, so it's very difficult for multimeters to measure that. But I can say 1000 Hertz is doing well. 1000 Hertz. Okay, so this is about alternating current, AC, True-RMS. We've done this before. DC 1619, pretty stable. I like that. Okay, let's see the old guy here. I'm not making compares. I just wanna. I'm curious. 16 something. 1609, 161, 1612, 1613. Okay. Well, this guy is very old. Very old. Perfect. The same. Good boy. Now, we are in ohms meter. Let me have a few resistors. What we got here? Okay. 87 ohms. Yeah, why not? 7.3 ohms. Really? Let's see. 8.19. What? No, I can't believe it. I can't believe it. 8.16. This is funny. Okay, let me have my low resistance meter. This is a really special tool. Really special tool. This one is, you know, it's measuring very low resistance, and not only it's measuring batteries internal resistance and a lot of other nice things. And we got 8.11 ohms. Okay, 8.1, 8.16. Let's see this guy, the old guy. Well, I wish to die when all the multimeters will be the same. I mean the same value, you know. If you know what I mean. That sounds funny, isn't that? 10.1, get out of here. 8.1, 8.6. And what about this guy? Once again, I will have the resistor like this. I'm not touching anything. Okay, something changed. 8.2. Yeah, it's in the range. So I think I done something wrong first time, of course. What we got here? 33 kilo ohms. Maybe I was touching the tester or something. No, this is 2.196 kilo ohms. Okay, 2.212 ohms. Okay. And evidently nothing, because this guy is made to measure low resistance. So I'm sorry, but I can't use that like a beacon, or but I can use the old guy. It was 2.2. Okay, let's go to 20 kilo ohms. 2.19. Yeah, pretty okay, pretty close. And this 2.19. That's it. I think it's okay. So I think the resistance, you know, the ohm meter, it's doing the job. Okay, let's have one of these big. So this is 47 ohms, 5 watts. 46 point, some bigger values, 100 kilos. Well, I'm pretty sure it's okay. 150 kilos, let's say. Until now, it's in the limits. Okay, this is 100 kilo ohms, 1.1. I'm not sure, but usually this one is doing a great job. Perfect, 101. Okay, so this range, it's covered with precision, and that's okay. I have a bigger one here, 220, 330. Okay, let's have this one. 330. Let's measure here first. What? 150.5. It should be. I don't understand. Okay, doesn't matter. That's why it's always a good idea to measure the components before doing any kind of projects. 150.8 to 150.5. Yes, pretty close. I like it. Yes, resistance is okay. The next one, it's beeping. Well, the first contact is it's not very fast. It takes like half a second or something, but the first one is kind of late. Listen. One, almost a second, no? But the others are closer. Okay, and we have a green LED there showing continuity. That's nice. Next, diodes and probably semiconductors of any kind, you know, transistors and things like this. Let's check for the diode. Minus, plus, nothing. 995. That's good. Done. Okay, of course I have a diode. Working great, as I expect. Do I have a transistor? What is this? I think it's a MOSFET. And check that right now. No, it's an NPN transistor. Very nice. So we have number 3, it's base. How we can measure this? Very simple. Just have the tester to the base, like this, one way and the other way. So this is good, and collector to emitter, nothing, and that means the transistor is working. Okay, the ohm meter, I mean the diode mode, it's doing the job. Next in row, it's capacitance. Okay, this is supposed to be 0.33 microfarads. Okay, it needs a little bit of time to figure that out. So it's 303 nanofarads. Yeah, that's great. 303.6. Beautiful. Can I fix it here? 302.2. Who's right? I don't know. What about this little one? 10 nano. Beautiful. 10.02. Very nice. Okay, 57.21 nano. 62.1. Well, it's kind of difference. I have another guy here. Oh, my old guy. I'm never count on this one, but let's try. Capacitance accuracy plus minus 4%. Range from 9 nanofarads to 9. Okay, then it's plus minus 5% for the big ones, let's say. So we have a 62 here, 63.25, 64. If we take this to this, I'm not sure who's right, but anyway, I think this is the best I can find. What about this? 19, it should be 20 nanofarads. And this show me 20.14. That's pretty okay. If we count 5%, 4 to 5% tolerance, I think it's more than enough. Okay, what about electrolytic? 3520 now. So this is a 35. How much saying? Yeah, 3.3 microfarads. That's electrolytic capacitor. 3.5. Okay, so this is pretty close, but it needs like 4. It needs 5 seconds to measure this thing. I may say it's pretty okay, you know, for hobby. I don't know how much this one costs. For now, I'm happy with it. Milliamps or millivolts. Well, I don't have anything here to measure millivolts. Maybe if I'm trying to measure my ohm meter on ohms, maybe I have millivolts. I have 1.76 millivolts. And this one shows around 10 mega ohms of impedance. Nice. Next, it's frequency. I don't have another solution, but to use this one like a generator. 50. Okay, let's try 50 hertz, of course. And nothing. Well, so it's not measuring square. Okay. 250. Not this one. And not this one. 10 kilohertz. I really don't know what to say, but let me try this guy. Maybe he's sending a sinusoidal signal. I know that we have a audio something here. There we go. Told you. So we have a 1 kilohertz, and that's true, it's 1 kilohertz and 54.8%. Well, I'm not sure, I have to check this. But anyway, I know this one is working with 10 kilohertz. But I'm kind of concerned, you know. So if it is a square generator, doesn't sense the frequency, 100 hertz? No way. Well, doesn't say anywhere if it have to be a sinusoidal or other frequency. Well, I'm not using that for measuring frequencies anyway, because I have my oscilloscope, so this is just an extra touch. Of course, the next one, it's the temperature control or temperature sensor here. 300, 400 in the middle of the flame, 642 and 44. It's working. Nice. This is good for my hot air station, you know, to check the temperatures. And what we got here, we have NCV, non-contact voltage detection. Well, I never used anything like this. Let me see. We have, look there. Okay, so let's check this function. Do we have any power? Okay, let me turn on the lamp. Right, and that shows us that there is life power. Okay, let me sit down here. Of course. This is nice. We can even follow the wires. Look there. Going up. We can follow the wires into the wall. Let me see this one. Is it here? Oh no, it should be up. Let's turn on. It senses the wires. And something else, when it's a strong signal, I mean a strong voltage, then it turns red. The LED up there, it turns red, and we have a hash that means high. When it's a weak signal, it's low. So that's supposed to be a distance or something. Anyway, it's a really interesting function, of course. The next one, it's milliamps. Okay, we should give a try with the multimeter here. Okay. Oh, so it's common. The other one, milliamps here. There we go. So we can give a try. Select, okay, this is DC. We can see, I'm gonna use my other meter, my old guy, on diode mode. So I'm pretty sure there is a current in diode mode. And that should be like, of course this one is saying it's a short, it's 1.588 milliamps. This is milliamps in DC. Milliamps in AC, True-RMS, we can give a try with this guy. So I can check 100 Hertz from this resistance meter. So it gives me like 5.7 milliamps at 0.997 kilohertz. And the next and the last, okay, so we have to take the leads out, I mean the testers out, and we are on amps current in DC mode. Okay, so it's beeping. It's warning you. You are in current mode. Don't do anything stupid. This is nice. You know, it was happening to me so many times when I supposed to have a meter or something, and I did a lot of mistakes like this. 10 amps, 9.999 amps. And we can do battery capacity meter. It's very simple. Like I told you before, just touch briefly plus and minus. 6 amps? Are you kidding me? No chance. 1.0. This is the value. 6 amps. No chance. Maybe, and this is very plausible, maybe the internal resistance is much lower than the classic. Let's call it classic already. And it's really taking a lot of current. But you know something? If my theory is okay, then we should have a result. 104 milliohms. This is the internal shunt. Let me see this one. Oh, no. Right, 1.2 ohms. Okay, so that's the explanation why this one shows such a big value for the batteries. That doesn't mean it's wrong. No, it's doing a very good current measurement because a very low shunt resistance. It's 100 milliohms. I'm really happy to know this, so I can count on this one when I'm measuring current with accuracy. You know, when you're having a good low resistance shunt, the probability of having bad results, it's null. And I think that's it for today. It's looking nice, it's elegant, it's functional, it's in the tolerance advertised. Also 3 years warranty, and I don't know about the price, but I'll let a link in the description. You can also use that link for having a discount. My opinion, my trusty, and how can I say, honest opinion is it feels solid, it's easy to read. What I'm missing, maybe a signal generator, you know, for injecting some audio signals, or let's say 1000 Hertz, that could be useful. So far it's doing the basic functions, and what I love about it's not too much buttons to press or to switch. It's solid, it feels good in the hand. I love this live sensor, you know, for AC voltages, and you know, following the wires into the walls. And I think you can even find, let's say you have an extension, you know, like 20 meter or something, and somewhere it's blown inside cable, you know, you can easily find what is the problem, you know, what is the discontinuity and stuff like this. Okay, finally, yeah, I should recommend something like this. We have to check about the price. I really don't know the price, but it feels okay. If it's in a range like maybe 40 to 50 euros, it's absolutely brilliant. Okay, thank you again, Kaiweets. This is KM601, a first test, and of course, time will say if it's doing the job or not. But for now, I'm pretty okay with that. And we'll see later if it's anything else to report. Thank you for now. I hope it's useful. Please like, subscribe, and don't forget to have fun. Bye bye.